Hello everyone, I am Reshma Totare, working as assistant professor in AISSMS IOIT. In today's session, we are going to discuss about Bresenham circle drawing algorithm. A circle is a set of points that are placed at a distance c. C is the radius given here from center point O. By Pythagoras theorem, a minus 0, 0, here origin x value as a 0, b minus 0 square is equal to r square. After simplification, we will get the result as a second equation. We can say y minus yc square is equal to r square minus xc. xc and yc we are considering here as a center point, and r is as a radius, and the point xy which is present on the circle boundary. After simplification, we will get the result as y is equal to yc plus or minus square root the result of r square minus xc square. This is not the best method for generating the circle. Problem with this method is that leaves uneven spaces and more computation at each step. Now, using the polar coordinate system, by using the parametric polar form to yield the pair of equation x is equal to xc plus r cos theta and y is equal to yc plus r sin theta. With this, we are displaying point at fixed angular step size. The step size chosen for theta will depend on the application. Now, to reduce the computation by considering the symmetry property of a circle, by using this symmetry property, there is no need to find each point on the circle. This complete circle is divided into 4 quadrants or 8 quadrants. Find one octant part, octant vertices, and replicate that one octant coordinate to rest of the 7 octants. For xy, calculation of xy, then we can plot the remaining 7 vertices xy, yx in second quadrant minus x minus y and minus yx. Like this, we can find out all the remaining vertices. With the Cartesian equation of Pythagoras theorem, multiplication and square root operations, in parametric equation we have performed multiplication and trigonometric calculation. Both the methods required more time. Bresenham method, which deals with the integer and perform only addition and subtraction, and these equations calculations are fastest as compared to the previous two methods. This is one more example of a symmetry property. Now we will discuss Bresenham circle drawing algorithm in detail. Here in the given figure, center point 0, 0 and two vertices a and b are present here. F of a calculation and f of b, we are applying here the circle function for both the vertices. First pixel a, the topmost boundary of the circle, is the point as a x0, y0. That values are, x value will remain same, it's a 0, and y0 will be as a radius r. A calculation, by applying the circle formula x0 plus 1 square plus y0, because it's present on the topmost boundary of the circle, r square minus r square. After simplification, we are getting here the value as a 1. The next vertex which is present here, that is b. For b, the vertex values are x0 plus 1, because it's moving on right side, plus 1, y0 minus 1. By applying the circle formula, after simplification, we are getting the value as x square, that means 0 plus 1 square, r minus 1 square minus r square. We are getting the result as a 2 minus 2r. Sum of f of a and f of b, after simplification, the result is 3 minus 2r. Now the second step, after addition of these a and b, sum of function a plus function b, we got the result as a sum 3 minus 2r. In current step, we are moving one step ahead. That means xn plus 1, that means this value, yn and xn plus 1 yn minus 1. This is the formula, this is this equation we are getting here. Now we have to compare that sum result with 0. If the results are negative, then by considering the vertex A, its values are A vertex values are xn plus 1 and yn. Like this, continuously we can call the remaining point as a pn plus 1, pn plus 2, like this. After that, SNU calculation by applying one more step ahead, that means xn plus 1 plus 1, that means xn plus 2 and the yn, this vertex, and the next vertex is xn plus 2 yn minus 1, one step below. After simplification by applying the circle formula, the SNU is equal to S plus 4xn plus 6 we are getting. For next pixel pn plus 2, we have to select point A if SNU is negative or equal to 0, else we can select the pixel as B. In step 2, if the S value is positive, then pn plus 1 as a xn plus 1 yn minus 1, find out the pn plus 2. SNU calculation here with the help of circle formula on vertex A and vertex B. After simplification, we are getting the result as SNU is equal to S plus 4 in bracket xn minus yn plus 10. Now we'll see Bresenham circle drawing algorithm. Create a octant of a circle. Here the angle is selected from 90 to 45. 1/8 of the circle. The algorithm calculate one new pixel per step. From any point xn is on the circle. Next point is xn plus 1, yn plus 1 must be either on the right or right and down. Pn is the current point with coordinate value xn, yn. Next point could be either A or B. Point A will having coordinate value xn plus 1, yn, and B will be xn plus 1, yn minus 1. For selecting one of these two pixels, we have to perform some test. That means we are applying here the circle formula x square plus y square minus r square. With this result, the results comparison with 0, that means the value is equal to 0, negative or positive. Based on that, the pixel decisions depend. That means pixel is inside the boundary if the result is negative. If the pixel is on the circle boundary when the result is 0. The pixel is outside the boundary when the result is positive. For point A, equation of the circle is f of A, the first equation, f of B, second equation. These are the various cases how to take the decision about the circle. Here A and B, both the vertices are inside the circle boundary. Therefore, the closest pixel we are going to plot, that means pixel A. A is on the boundary, B is inside the boundary. That time we have to plot the pixel as A. A is outside the boundary, B is inside the boundary. By taking the addition of f of A and f of B, the results are like positive, negative and 0. If the results are negative or equal to 0, plot A. If the result is positive, plot B. Here f of A is outside the boundary, value is positive, B is on the boundary, plot pixel B. Both the pixels are outside the boundary, then plot B. This is the summarized results of both the vertices, negative, 0 and positive results. Based on that, both the results are negative, the sum is negative. A1 vertex is a 0 on the boundary and one negative result, final result will be negative. One is positive, negative. In this case, the any negative, 0 or positive possibility is there. Positive 0, positive possibility, and positive result will be positive. Starting point P0 is taken as x0, y0, that means 0r. That this point we have covered in the figure. In this figure, we have discussed this point already. R is topmost point of the figure of the circle boundary and 0 x value. With this, we are going to calculate x0 plus 1 y0. By applying the circle formula, we are getting the value as a 1. And for second point vertex B, x0 plus 1, y0 minus 1, we are getting the result as a 2 minus 2r. The summation of this f of a and f of b is 3 minus 2r. By taking the sum of function a and function b, the result possibility is negative, positive or equal to 0. If the sum is less than 0, then call point Pn plus 1, next point Pn plus 2. After that, SNU calculation with the help of xn plus 2 yn, xn plus 2 yn minus 1, xnu minus s. After simplification, we are getting the result as SNU is equal to s plus 4xn plus 6. For step 2, if the sum result is positive, then Pn plus 1 as a xn plus 1 yn minus 1. After that, calculate the SNU value by using the second step x and y value. That means we are moving on the right side xn plus 2 and yn moving downward direction, therefore yn minus 1, and for second step yn minus 2. By applying the circle formula after simplification, we are getting evaluating the previous sum result here in current step. SNU is equal to s plus 4 in bracket xn plus minus yn plus 10. Finally, we will get all the vertices octant 190 to 45, all the vertices which are present on the circle boundary, and with the help of symmetry property we will finally get the complete circle boundary on the screen. Thank you.